In this lesson, we'll look at how to declare an array and how to access the information in the array. Also, how can I use it in math and printing maybe the array and other basic algorithms that can be used with an array. So when I declare an array, we need to declare it either to be of constant type or to be of character type, just like we did with our variables. And we would use the idea of the dollar sign to indicate characters versus not having a dollar sign to indicate constants. We use the keyword dim, and that indicates for us that we are declaring a variable to be of a dimensional type. So we would have the keyword dim, we give it its name, and we give it a size. Whenever I declare a multidimensional array, I need to give it a row and column size. So that would look like this. So here I am creating one of character type, okay, because I've added the dollar sign onto it, and I am giving it a size 10. All right. It's one dimensional because I only have one number here. So this is going to create one of size 10, remembering that it's going to be indexed from 0 to 9. And I missed one right here. Size 10. There are 10 mailboxes here adjacent to each other, index 0 to 9. Here we're creating a two-dimensional array. It has a row and a column. So it's going to have 25 rows. Okay, so 25 rows, remembering that rows go across, so this would go 0 to 24, and it has two columns, column 0, column 1. So it would look something like this in memory. This one holds all characters because of the dollar sign. Here I'm declaring, I can declare more than one at any time, and so this one is declaring two one-dimensional arrays. This is one two-dimensional array, where in this example here, I am declaring two one-dimensional arrays. 1, 2. And so this one is named dollar sign that has 10 locations. This is ID number. Now take notice to the difference here. This guy has a dollar sign, so this one's expecting characters. This one has no dollar sign, so it's expecting numerical values that I could math with. Okay, a dim statement, you can only execute a dim statement once for an array of a specific name. So I can't use a goto and go back to line 100 and have it redefine this line. That will give us a redefinition error, and so you need to be mindful that your algorithm does not bring you back to line 100 in this example, and otherwise you will get an error from it. So we have array name, array size, a multi-dimensional array, and then here we're declaring two arrays at the same time. I can declare 3, 4, 5 arrays. I can declare them on separate lines if I wanted to. When writing with arrays, an array can be used with any keyword that I use a regular variable with. So the let, the read, the input, the print. I can use a formatter with an element from the array. So all of these things can be used like I would with a regular variable. So in this example here, now the difference here than using a regular, variable, this says A is equal to 328. This, remember, A is a single mailbox that takes on the value of 328. This, with the parentheses and a number, indicates that I have created an array that has some size to it. I don't know for sure the size here. All I know is that the array at index 6, 0, 1, 2, 3, 4, 5, 6, is going to be assigned the value 328. All right, this is the address. Called 6, which is the 7th element of the array. 0, 1, 2, 3, 4, 5, 6 is the 7th mailbox in the array that I'm going to put the number 328 into. I can read into it, so this statement here would read from the data line. Again, it's reading in at the same location, that 328. I can also use an input line, and assign, like I would a regular variable, I can assign a specific location. Whenever I reference an array, I must always reference an address within the array. This one is multidimensional, so somewhere within this multidimensional structure, we are going to assign at the location 12.1, we are going to assign whatever the user enters from the keyboard. So we have direct assignment, we have the ability to read, we have the ability to input. We also can print from the array, okay? In the same way that we printed a variable, again, the only difference is that I need to include an address, all right? I need to include what mailbox do I want to print from. I can't dim an array. Let's say I've created the array of size 10 called A. I can't just tell it to print A. All right, it won't print all of the values in the array. I actually must access each value of the array individually in order to print it. So you need to be mindful of that when I declare an array, I must always have an address, a set of parentheses with some number in there. And so I can use a formatter. So here we're tabbing over and then I'm printing the value that's stored in the array. Here I am printing whatever is stored in mailbox address 12 from an array called named $. So we are retrieving only a copy. So that 328 from the previous slide that was stored at A6, it's only going to print a copy. So 328 is still stored in there. I didn't remove it from the array. It's still in there. It only takes out a copy of it. The only way that 328 can be changed is if I overwrite it, which I could overwrite it using a let statement from the previous slide, an input statement, and so on. I can calculate with elements of the array in the same way that I used variables in my math structures. I can use a reference to an array doing the exact same thing. So what it's going to do in that first example is it is going to retrieve a copy of whatever stored in mailbox address 3 of array A and mailbox address 7 of array A, and it's going to add them together. It's going to retrieve a copy, add them together, and assign it to the variable mailbox called X. Okay, X is not an array because there are no parentheses and there isn't an indicated address. Versus the next example. Here I can let, through direct assignment, the value at address 9 of array A, I can retrieve a copy of what's at address 2, in this case multiply it by 3, and assign it in. So this would actually overwrite. If something's already stored there, it could overwrite what is stored in the array through the assignment. And then also retrieving here through printing, I can use a variable here. Okay, so that, like in a looping structure where we've used variables, like the counter and things like that, and we can do that here. And so I can use a variable that represents an integer value. Addresses can only be integers in an array. I can't use decimal addresses. They can only be integers. So what about a loop? So this is the beauty of an array structure and having the ability to use a looping structure. Here we declare two arrays. We declared two one-dimensional arrays. So I have an array called name $, which has 5 elements in it. 1, 2, 3, 4, 5. Sorry, we have a little too much there. And then another one. And so one is going to hold characters and one is going to hold numbers. And so here is name $. Here is age, the array. And what's going to happen here, so we set row is equal to 0 to 4. And so the idea that the row is going to be used for the addressing. So it's going to read into array name $, at row 0, so right here. Okay, at address 0, and it's going to assign AlvarX. It read AlvarX out of the database and stored it into the array called name $, at 0. it's going to assign age at 0. It's going to assign what it read out of the database. So it's going to read 15 into mailbox address 0. It says next row, so it's going to go up, increment row to 1, and so this is going to change to a 1. So it's going to read Argo and assign it into the array named $ at 1, and 14 into array age at address 1. It's going to repeat that again, read Morris and 17 in. Now this example is going to give me an out of data error, but normally, using a for loop, we would use the right number of elements in there, but I can fill my array using a looping structure, and we will use this to kind of ease our interfaces so that we don't find ourselves having to enter something 25 times into the array, because that gets to be a little annoying after a while. But we will be able to read. I could change this to a print, and I can print the elements from the array for us, okay, by just changing that keyword. I could change that to an input, and then the user from the keyboard can input all of the elements that go into named $ and into age. I would include a prompt in there and so forth in order to do that. So a looping structure, along with our other keywords, would allow us now to manipulate either through printing, I can fill it, I can access it, and so forth. So we're creating the array, we start the loop, we read into the array. Okay, now notice that the for loop indexing is off by 1 from the size, and I've been saying that since the first slide in the previous lesson. Size 5, but it will be indexed from 0 to n-1, so 5 minus 1 is 4, so this one is indexed from 0 to 4 in memory. So some final considerations with array: the off by 1 error. The idea that indexing starts at 0, not at 1. At the natural counting number of 1, it starts at 0. So the last element in the array, the last address, would be n-1. And that goes back to that previous slide of using 0 to 4 in my looping structure, because I used the counter for my looping address. There's an out of bounds issue. If I attempt to, so in this last example, let's say I wanted to print named $ at address 10. Well, this only had 5 elements in it. There can't be a 10th mailbox. And so that would produce an out of bounds error, because I tried to access an element that doesn't exist because we've tried to access an address outside of the boundaries of the array. So that is something to be mindful of. By default, a numerical array will fill itself with zeros. So when it creates it, it will fill it with zeros. So if I tried to print it out without reading anything into it or assigning anything to it, it would print zeros for me. However, by default, a string array like named $ will fill itself with what we call a null value, an empty. Null means empty. So it would actually be empty. So if I tried to print these before I filled them, I would get for named $ nothing to print. But from age, because it's of constant type, I'll get all zeros. Okay, so by default, it does give it default values of the empty set for a string array and a 0 for a numerical array.